So RIP information protocol is basically a dynamic routing protocol which uses hop count as a routing metric to find the best path between the source and the destination network. So it is a distance vector routing protocol which has AD value 120 and works on the application layer of OSI model. RIP uses port number 520. And now let's move on to OSPF. So OSPF protocol is a link state routing protocol, which means that the routers exchange topology information with their nearest neighbors. And now let's see the BJP, which is Border Gateway Protocol. So basically, BGP refers to a gateway protocol that enables the internet to exchange routing information between autonomous systems. So now let's see the RIP version 1. So RIP version 1 uses classful routing. The periodic routing updates do not carry subnet information, lacking support for variable length subnet mask VLSM. This limitation makes it impossible to have different sized subnets inside of the same network class. In other words, all subnets in a network class must have same size. There is also no support for router authentication, making RIP vulnerable to various attacks. So now let's see the RIP version 2. So RIP version 2 is a classless distance vector routing protocol as defined in RFC 1723. So being a classless routing protocol means it includes the subnet mask with the network addresses in its routing updates. Due to the deficiencies of RIP version 1, RIP version 2 was developed in 1993 and was equipped with the ability to support subnet information and supports classless interdomain routing. Now let's see the difference between RIP version 1 and 2. So here as you can see the chart on the screen, so these are the differences. First one is RIP version 1 is a distance vector routing protocol, and RIP version 2 is also a distance vector routing protocol. And the second difference is it also supports classful network, but RIP version 2 supports classful and classless networks. And the third difference is it does not support RIP version 1 does not support for authentications, but RIP version 2 supports authentication. And the fourth difference is uh, hop count limit is 15 for RIP version 1 and it is same for RIP version 2. And the fifth difference is RIP version 1 does not support for VLSM and discontinuous networks, uh, but RIP version 2 supports for VLSM and discontinuous networks. So as we saw previously on the 8th slide that RIP version 1 is less secure, and to overcome that problem, RIP version 2 was created. So definitely RIP version 2 will be more secure. And now let's see the seventh difference. So RIP version 1 use broadcast traffic for updates, but RIP version 2 uses multicast traffic for updates. And now the eighth one. So RIP version 1 does not provide trigger updates, but we get trigger updates in RIP version 2. And in the ninth one, RIP version 2, RIP version 1 not send subnet mask to routing table, but for RIP version 2 send subnet mask to routing table. And the last last difference is that RIP version 1 don't support manual route summarization, but RIP version 2 support manual route summarization.
Yeah. Thank you, Vishal. Don't unshare. Let the screen be here. Am I audible, Vishal?
Yes, sir.
All right. So, thank you so much for this presentation, and that really, I'm really glad that you have prepared for this seminar, and you are ready. You said you are not ready, but I could see that you are fully ready to present this. So, appreciations to you, and God bless you. There are 2 points. There is the point on number 7 on the screen. Repotion 1 use broadcast traffic, whereas Repotion 2 use multicast traffic, which we have seen in the previous class, right? So when I was presenting, Repotion 1 was sending the broadcast update using 255, 255, 255, 255, whereas during Repotion 2, we witnessed that it was sending to 224 dot some numbers, all right? So 224 comes under multicast. That is point number 1. Point number 2 is on the 8th one on screen. Repotion 1 does not provide triggered update, whereas Repotion 2 provides triggered update. I just wanted to highlight on that in case any of you haven't read about that. Vishal, do you want me to explain that? You have learnt about that, triggered update, things like that?
Sir, I think you should now explain.
I'll proceed. Okay, fine.
Yes.
So yeah. So when you talk about the RIP version 1, he has claimed that it does not provide triggered update. All right. You can
Yes.
take the literal meaning of trigger. Yes. So triggering is something, a normal process is going on. Suddenly there is a change which will trigger something else to happen. That is the meaning of triggering. Okay, somebody might be very calm, very quiet, lovable. Something would have triggered him to be, to become arrogant or to avoid his normal process and so on. So when we talk about repotion 1, when there is a topology change, for instance, there is a link between router 1 and router 2. All right. Suddenly that link fails. Now, the route has to be restructured. I can give you an example. You are all here during your first year. So we are in the computer science block. We also were knowing where our computer technology center, CTC, is housed. All right. It is hardly 100 meters between CTC and us. And we are getting internet connectivity from the CTC. Of course, they are the nodal points. So this block is getting the internet connectivity through the CTC. And there are 2 paths. There is a redundant path available between us and CTC. One is through the media center. The other one is through the Department of Mechanical Engineering. And these 2 switches are managed by 2 different UPS connections. Okay. What happens sometimes due to malfunction or some issue, one of the UPS may fail. When there is a power fluctuation, the UPS may fail. Suddenly what happens, there will be a reroute. So if we were getting the internet connectivity through the switch from the mechanical department, when there is a UPS failure, the switch goes off, then the redundant path is chosen, which is through the media center. Okay, so there might be a small transient failure in the internet, but it will be suddenly restored. All right. Now there is a suddenly the power comes back. The UPS issue is rectified, and the switch is back. Now what will happen? There will be another reroute again that the old route will be restored and there will be a small transient internet disconnection because the reroute is happening. This is called, probably this can be taken as the triggered one. When there is a sudden failure in the link or the router, the system, the routing protocols will go for a new route. Whereas in the case of reversion 1, that is not available. All right, the routing, the topology changes will come into effect only after 30 seconds. Okay, 30 seconds is called hello timer. You can learn about reversion 1 more to know about this. All right, there is something called hello timer for 30 seconds. So for every 30 seconds, there will be an update. All right. Whereas in the case of reversion 1, when there is a topology change, suddenly the update is sent. That is called triggered update. Otherwise, reversion 1 and reversion 2, they both support periodic updates for every 30 seconds. But when there is a topology change, reversion 1 does not respond, but reversion 2 suddenly sends the topology change information to the neighboring routers for finding the best possible alternate route. That is about the triggered update. And the final one is the route summarization. Route summarization is almost, no, it is a route aggregation. That is exactly the reverse, logically, no, logically exactly the reverse of your subnetting. So you got slash 24 as the network, and you may borrow one bit to create two subnets with the mask 25 slash 25 each. That is called subnetting. But when you summarize it, when you aggregate it together, you will get the summary route. All right. So multiple subnets will have the single summary route, that is called summarization. In the case of reversion 1, it supports manual route summarization. You can do it manually and you can redistribute, but that is not supported in reversion 1. Okay, these are the points I just wanted to add with what Mr. Vishal has shared with you. Otherwise, he had covered almost everything which is supposed to be covered as part of this. However, I recommend you to continue reading your textbook and other materials as well, to know about this further. All right. Thank you, Vishal. Thanks for your time once again. You can unshare. I have a small, yeah. So I have a small PKT file to explain to you about OSPF protocols. Vishal, with your permission, shall I mute yourself and you can unshare your screen?
Okay, sir.
All right. So I have put Vishal into mute, but you can unmute at any time in case you have any query. Patrick, you can go ahead with similar presentation if you want, probably a better presentation this Friday.
Okay, sir.
All right. Fine. Thank you. All right. So if any of you have any question, you can put it in the chat box. Probably I remove this headset for the time being. All right. So let's proceed. As I said, I will share the screen where I would explain to you the configuration of OSPF protocol. Vishal was sharing with you the three kinds of routing protocols, right? One is about the RIP version 1 and 2, which comes under distance vector routing protocol. The second one is the open shortest path first, that is OSPF, which comes under link state routing protocols. All right, so I'm going to demonstrate to you the configuration of OSPF today. The final results would be very similar to RIP version 2, but the configuration commands are slightly different, whereas the whole of their functionality, how do they work, is entirely different. All right, in the case of distance vector routing protocol, every router shares only their routing information with the neighbors. All right, whereas in the case of link state routing protocols, all right, it is exchanging the routing topology, the whole of the topology in the link state updates. That is something called LSA packets. It's my appeal that you will explore further by yourself. Due to limited time, I'll explain to you only the configuration of OSPF protocol today, and then I leave the theory content for you to do the self-learning. So in the next class, we'll jump into IPv6 and the comparison of IPv6 and v4 before we get into BGP and DHCP and other things. All right. So I share the screen. Yep. So I believe my screen is visible. So I increase the size a little bit, screen size, that it will be visible to you better. All right. You could have seen the same configuration in the previous class where I have used the same topology to explain to you RIP version 2 and also the limitation posed by RIP version 1. And I also justified the necessity of RIP version 2 in the configuration. All right. Today I'm going to use the same topology. However, these are not having any routing protocols configured. I can show that. I go to enable. I say show run. No, let me say show IP route. I have given show IP route. You could see that this router 0 has got only two networks connected. That is 192.168 1.0. The other one is 192.16.16.0. These two networks are connected to router 0. We can also check one of the other routers using the inspect tool. You could see it has only three networks connected, this, and this. So apparently, I could see that there is no routing protocol configured, but still I'm not convinced. I can go to the other router and see whether any routing protocol is configured. I go for show running configuration. I carefully look at every line. Yeah, I could not see any routing protocols configured so far. Right now, this is a simple topology which has got all its IP addresses configured. How can I verify? I just try to check the connectivity among them. If this is successful, it says this is successful. PC 4 to 5, it says it is successful. I'll keep it somewhere here. Yeah. And then these three are successful, which means the LANs are having connectivity among themselves. And probably between these two, yes, it is successful. Another random verification. So far, things are good. All right, there is nothing failed. It's successful. All right. So far things are okay, which means all the LANs are having connectivity with the routers, their default gateway, and these LANs are connected to the default gateway and so on. Let's also verify whether they have the connectivity among themselves. It failed, 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 failed. I don't have any hope that they have, because I know that they cannot ping each other. The reason is routing protocols are not configured. All right. Hence, I go for configuring the routing protocol here. As I promised, we'll go for OSPF configuration. So I have typed the commands here. This is the it's not sample, but this is the format. Okay. So I'm supposed to get into this mode, and I should say router, OSPF, and process ID. Unlike RIP protocol, OSPF process can be run in more than one instance. Okay, with process ID 1 and then process ID 2, 3, and so on. So you can have n number of OSPF processes running on the router, unlike your RIP protocol where you can have only one instance. Second one, in the case of configuration of network, very similar to your RIP, you have to use network and the network ID. Instead of subnet mask, we should go for the wildcard mask. Wildcard mask is the complement of subnet mask. For example, if your subnet mask is 255.255.255.0, wildcard mask is 0.0.0.255. Okay, it is exactly the complement of the subnet mask. If the subnet mask is 255.255.255.128, then the wildcard mask would be 0.0.0.127. Right? So these two sum together will give you 255.255.255.255. That is called wildcard mask. So this wildcard mask has an important characteristic that you can specify the network clearly, unlike the subnet mask where you can go for this longest matching, this whatever matching happens, it will go. But when you take the wildcard mask, it will go for this specific network. So that's the advantage. Router OSPF protocol expects the wildcard mask to be configured. Not only that, we also are supposed to add another keyword called area with area ID. And in our configuration, we are going to go for a single area OSPF. Hence, all this area ID, whenever you are configuring this OSPF protocol in all these routers, we should go for the same area ID. In today's example, I'm going to use area as 0, right? There is something called multi-area OSPF, all right? For NSSP, not so stubby area network. So there are multiple kinds of OSPF configurations available, which are all part of our CCNP curriculum. If any of you are interested in CCNP who have completed CCNA, kindly let me know. I will give you CCNP a course free of cost from Karunya. We'll bear the cost. but you can do the self-learning. We'll give you the course materials. There will be a possibility that you can take up the industrial certification also at the very reduced cost for your own benefit, provided you have completed CCNA certification. All right. So if anyone of you are aspiring to complete CCNA, please do it at the earliest and let me know. I will enable the CCNP course content to you absolutely free because you are my students. All right. Fine, I'll explain to you the configuration of OSPF now. So I go to this router as usual. I go to the CLI. I'm in the CLI. So how can I configure OSPF protocol? As usual, I should go for configure terminal. Okay, I have given configure terminal, and then I should enable the OSPF process. So I should say router OSPF, and then the process ID. I give one. Wherever I configure OSPF in our class, I go for one so that there is no confusion. Okay, router OSPF one. So there is only one difference here between RIP and this, where you used to give router RIP, right? But here we give router OSPF. We also add the process ID. I have added as one. And then I should go for network command, which is very similar to our RIP configuration. And I have to advertise the connected networks. All right. So I'm going to say advertise about this 192.168.1.0. And the next parameter is supposed to be the wildcard mask. What is the subnet mask? 255.255.255.128. Why? I'll write here. Okay, the network address is 192.168.10/25, as you could see here, right? This is /25, which means 192.168.10 with the mask 255.255.255.0. Now, this is subnet mask, but what is expected in OSPF configuration is the wildcard mask. So how can I find out the, no, this is not 128, it is not 0, it is 128. I'm sorry, because the mask is 25. Okay, it is 128. So how can I find out the wildcard mask? Very simple, sir. You just say 255.255.255.255 minus, you have to subtract it, right? So what will you get? 0, 0, 0, 127. All right. This is called the wildcard mask. So I go ahead with configuring this this one. So 0, 0, 0, 127 is the wildcard mask. And I should not forget to include the keyword called area. And I said that I'm going to use the area ID as 0. Right. So this is the configuration of OSPF. Simple, but it is not over yet. I'll keep it here. I have to also advertise this network. So I'll go for network 172.16.16.0. For 25, we know the wildcard mask 0, 0, 0, 127 with area 0. Okay, area 0. Right, these two are done. Now I copy this running configuration to startup configuration in case if there is any power issue. All right, so I have configured router 0. A similar configuration I should do for router 1 as well. I close it. Right, I open the router 1, enable configure terminal. What should be the command? Router OSPF 1, right? Process ID is 1. And I should advertise these 3 networks, right? So network 172.16.16.0, wildcard mask we have just learned 0, 0, 0, 127 with the area 0. All right, and I'm also going to give 128. Why? This one 172.16.16.128 with the mask 25 becomes this. I press enter. You could already see the OSPF has started sharing the adjacent through process 1. All right. All right. And I'm also supposed to exchange about this network. So network 10, 10, 10, 10, 0, 0, 0. with the mask 24. So if the mask is 24, what should be the wildcard mask? Mask is 24, which means 255.255.255.0. So what should be the wildcard mask? 255.255.255.255 minus this one, right? You'll get 0, 0, 0, 255. You got it? So this should be the wildcard mask for this router. So I give 0, 0, 0, 255 with area 0. All right. So I have advertised these three networks now. And for safety, I copy the running to startup configuration. All right. So I close it. Go to this router. So in this router, let me give config T, router OSPF with the process 1. And what are the networks I'm supposed to share? It is network 172.16.16.128 with the wildcard mask. It is /25. So it is 127, then area 0. And I'm also supposed to give a network 192.168.1.128, the mask 0, 0, not comma, 0, 0, 127 with area 0. Okay, area 0. So when you are typing the command, in case you are getting some messages like this, don't bother. You can continue typing, and that will be taken as the continuous one. Okay. And I also copy this into NVRAM. I have done it. So that it may take little time for convergence, but I don't have the patience. So I just use the Easter egg to do that. I feel it should have got all the information. Anyway, I can show IP root. Yes, good. So I have given the show IP root command, and you could see that. Okay, this may not be much visible. Anyway, I'll copy this and paste. Copy and then paste here. Hope this is visible. We don't want all these things. I'll just say delete this. All right, we need this O. Okay, it says gateway of last resort is not set. Let's not bother about it. So IP root gives you some commands. So C is for connected, O is for OSPF. Okay, D for AHRB, R for RIP, and B for BGP, and so on. All right. Now it says there are two connected networks. Both are indicated by C. There are three networks which are LAN through OSPF. This one, and this one. Okay. If I continue the story for the other router, I can go here. Show IP root. It has got three networks connected, and it has LAN another two. I'll use the inspect tool to look at this. It has got two networks connected, and it has LAN 3. So for me, it appears that things are okay. But still we have to verify the end-to-end connectivity. Then only we can convince. So I go to this machine, I click randomly, it says successful, right? So that's clear. Maybe another random points failed, no problem, it is successful, right? So this is how we are supposed to configure this OSPF protocols. And you also can use the command debug OSPF. Okay. Oh, it's not here. Okay. Debug IP OSPF. I think events. You have events. We have got adjacency and events. I can go for events. Events on. All right. So you could see how this OSPF is communicating each other. So debug IP OSPF events. This all here also I have opened this. So you could see that you are receiving the hello message from the other side. And let me see whether there is a triggered update. No, I do not want to take a chance now that there will be a loss of connectivity. All right. So there are a lot of exchanges that are happening. So I can even say um, debug IP OSPF adjacency. Okay, we'll see how the adjacency is happening. It's only the events. So debug IP OSPF adjacency. We'll see whether any adjacency communication is happening. Let's wait. Hmm, so far, no such messages. Okay, I could not see. All right, so this is the configuration of OSPF, but there are lot of troubleshooting commands are also available in OSPF. I would encourage you to learn by yourself the various commands. All right, because I have done my best to explain to you the basics of configuration of OSPF, but it can be built. OSPF metrics are very interesting one. How the and also learning about EHRP is really fun. Okay, so please explore EHRP protocol as well. And then we can go to BGP to learn about the border gateway protocol for the routing between the autonomous system. All right, so with this, I stop sharing.